Hello students, welcome to chapter 7 alternating current, in which we are discussing three important AC circuits for pure resistor, inductor and capacitor. Now these three are the important components are there for the electrical circuit. Let us first see what exactly these components are there. The first components we can call it as a resistor. This is the component of a resistor. Now this is a circuit symbol for that one. It is shown like this. The second component is inductor. Second component is inductor. The circuit symbol for the inductor is given by like this. And our third component is there. This is the capacitor. Capacitor circuit symbol is given like this. This is C now. As I told you, now these three are very important and indispensable components are there. Now what we are studying now, in this circuit we are studying current, and so we studied about voltage, whether these two are in phase or out of phase now. This discussion will be done here. But first of all, for the voltage, we are using an AC source. This is the symbol for AC source is there. For this symbol, the voltage is sinusoidal given by V0. This is sine omega t. Now all the frequencies of voltage is same now. The first case becomes I is equal to, this is I0. Now this remains as sine omega t. This is for the first circuit. First circuit I is equal to I0 omega t now. Second circuit you come, I is equal to, this is I0, this is sine omega t here. Now this happens to be minus pi by 2. Now see here there is a phase difference is there. And third circuit is that becomes I is equal to I0. Now this is sine. Now this becomes as omega t plus pi by 2. Now compare these two, and you're talking with respect to the current here. You can say in this case what happens now, it is leading and in this case it is lagging now. That means the current is there. If you compare voltage and current now, each other have a phase difference of pi by 2, here also pi by 2 is there. One of them, that in this case what happens, the voltage is leading, and in this case it is current is leading now. So because of that, these circuits becomes very important now, and now discuss the circuit one by one in detail. Now this is the first circuit is called as a resistive circuit. In this circuit we want to find current and voltage are in phase. Then AC circuit containing a pure resistor. Now this is the circuit is there, and this circuit consists of the component is called resistance now. How this component is? This component consists of R now. This resistor is there. And they have shown the current here. This is the current is flowing into the circuit shown by the red color. And also this is called the AC generator. And this AC generator voltage is given by V is equal to V0 sin omega t. Now same circuit is shown here, and you can find out that the two graphs are there. The two are there. You can say the voltage and this is called the current now. Both are maximum at the same time. And again both are minimum at the same time. You are calling that the current and voltage are, this is called as in phase. Current and voltage are called as in phase now. Let us mathematically derive this one, how they are in phase now. Let us first take one equation, and this equation is written like this. V is equal to, now this is V0. Now this happens to be sine omega t. This is first equation. Now what this equation represents now, this equation is telling us that the voltage from the AC generator is coming this much now, where V0 is the peak value of the potential difference, and omega is angular frequency, and t is a time now, and omega is angular frequency now. Now from Ohm's law we can give here I is equal to, this becomes as V upon R. This is from Ohm's law. I can write here, this is Ohm's law. You can write here. Now therefore that above equation, from 1 you write it as V naught, this is a sin omega t whole divided by R. You modify this equation right here, this is V naught upon R and this is sin omega t, or you can write this equal to I naught, this is sin omega t and this is called as I naught. This is called equation number 2 here. Now compare both equation now 1 and 2. Now here what happens, when you observe that the phase difference is 0. Difference is 0, or you can say they are in phase now, or you can say they are in phase now. That means what is the inference here? In AC circuit consisting of pure resistance, the two current and voltage both are in phase now. There is no phase difference is there. You draw the phasor diagram for this one. Then what you can do now, this is a one for the voltage you can say across the resistance, and you can draw this is for the voltage across the your resistance. Sorry, this is a current across the resistor. I can correct this one. This is IR, the current across the resistance is there. That means what this tells us now, the voltage and current are there, both are in phase in this case now. That is why this circuit has got importance is there. This is a current and this voltage both are in phase now. You can conclude that in this figure it shows that current and voltage are in phase. Let us come to the another circuit now. Another circuit is a pure inductor. Now you can see the pure inductor, what you can find here. You can see here the first thing. Now this becomes V is equal to V naught. This is sin omega t. This is equation for the AC source. That is given for this one. Then this happens to be say voltage and current are there. This shows that they are not in phase now. You can say current is here and voltage, that means voltage is leading the current here. You can see this figure, voltage leading into the current is there. Let us mathematically find out how they are leading each other. First thing, we can take the same expression which was taken for the current. Now that becomes as V is equal to, this is V naught sin omega t, you can call it as equation number 1. Then now here this becomes E and this is can be written as I into R here. What is R now? It is the resistance for the inductor now. For a pure inductor, this R is equal to 0. That means what happens when this is 0, then it becomes as V plus E, that is equal to 0. Then V plus E is equal to 0. You know that this is E is equal to, for the inductor, minus L. This can be written as, this is di upon dt for the pure inductor. L is the inductance value is there now. Then this equation I'll substitute here. Now this becomes as V plus this value. Now this value is your minus L. This is di upon dt, which is equal to, now this becomes as 0. I am substituting this expression, the value of d now, that becomes equal to 0. Or you can write L into di upon dt is equal to, now this becomes to be V now. And we want current here, that means we are writing here di is equal to, now this L in the numerator comes to the denominator, now this becomes as V upon L and this is a dt now. You can call this another equation. This is our second equation and this happens to be your third equation. Now this is equal to, I can write from, this is V naught, now this becomes as sin omega t upon, this is L and into dt now. This expression can be written it like this. Now this is I is there. From this we wanted to find the value of the I now. Di is given, I want to find now. To find this I, we wanted to do the integration for this one now. Now this integration like this, integration of this becomes di and this V naught upon L is constant, to take it here now. This becomes sin omega t into this is dt now. Now integration of sin omega t is minus cos omega t upon omega, and this becomes as I is equal to, you write V naught upon L and into bracket you write minus, this is cos omega t whole divided by omega now. Now this becomes that integration of this one. This gives the value for the cos. Value is for the given for the cos value here. Now further we want to simplify this, that you write here in this corner we can write I is equal to V naught upon L, and this is minus cos omega t is there, we can write it as a sin omega t minus 90 now. Now this becomes as I is equal to I naught, this is sin omega t minus this is pi by 2 now. Now this shows that the equation that is minus pi by 2 what is coming here, that voltage leads the current by 90 degree here. This is the phase difference is there, that voltage is leading current by 90 degree now. That means this is case of the inductive circuit, both are not in phase now, voltage is ahead of the current now, and you can find that they are shown like this, the graph now whatever I studied in the previous case now. Now let us come to another circuit now, that current and voltage are in phase in AC circuit containing pure capacitor now. In phase, they are not in phase now actually, they are not in phase are they. Let us please check it up now. This becomes as V is equal to V naught sin omega t now. This is V naught sin omega t as if we have done now. Now say voltage and current you can see here, they are not in phase now. Now voltage is comes a little bit later, that you can see current leads the voltage in this case now. Now this can be mathematically discussed as below. That means we are coming for the expression for the capacitor now. This capacitor also shows the values like this. We can go the first equation, V is equal to V naught. Now this becomes as sin omega t, equation number 1. But in the capacitor the voltage becomes, that is Q upon this is C. This you can call it as equation number 2. That means here LHS of these two equations are equal. You can write Q upon C is equal to, this is V naught sin omega t. That means Q upon C is equal to V naught sin omega t, or you can write Q is equal to, this is C V naught, this becomes as sin omega t. This you can call equation number 3. Then we know current is equal to dq upon rate of change of charge. You can write for this one now. This becomes as I is equal to the differentiation of this one now. That means I can write d upon dt of, you can write C V naught, this becomes as sin omega t. Differentiation of this one, then this derivative of sin theta becomes cos theta. That means you can write here, now this I is equal to C V naught, this is cos omega t into this omega now, because it is a composite function is there. I can write here I is equal to omega C V naught. Now this becomes as cos omega t. That means this is after differentiation we got the cos omega t now. That means you can write this also simply C V naught. This is sin omega t. This is plus pi by 2. That means this becomes I is equal to I naught, you can write sin, now this is omega t plus this is pi by 2 now. Plus pi by 2 is there. That means here current leads the voltage by 90 degree now. Now these are the 3 circuits are there. In these circuits we can find the like this. In the first case what happens now, the voltage and current are there, they are in the phase now. You can see this circuit now, here they are both are in the phase, voltage and current are phase here. They are in phase means they are going at the same time, they are in the phase. And these values, the coming to the second one, you can see in the one now, current and voltage are there now. Here voltage comes first, then current, that means it is voltage leading the current here, but in this case the current is leading the voltage here. Here voltage is leading. Now these are the 3 important circuit diagrams are there which are usually into the AC circuits, and I shown some actual components here. These are called the resistors now. You can say this is a photo for the resistors now. and this is photo for capacitors, and these are the inductors. Now these are the components, they are present in almost all electrical circuits. Now without these components there is no electrical circuit at all. Now this is the actual components mounted on the PC board into the many of the circuits. That means this is called printed circuit board now. The AC circuit resistances are there, capacitors are there, inductors are there, which makes an integrated circuit, and that the circuit operates now. Now thank you very much for watching this video. Hope you are all happy with this one. Thank you one and all.
Yes,